It's Maths O'Clock with Mr. Hlajwayo. Welcome to another video.
So we are beginning with our theorem 1. So if this is your well-drawn circle like mine, and now this is your center. We say this is your center O. And we are saying now you are required to prove that now a line drawn from the center to perpendicular to the chord bisects the chord, right? So this is your first theorem, or this is your theorem. This is your theorem 1, right? So now, what are we required to prove here? We are required to prove. We are required to prove that now, if a line drawn from the center perpendicular to the chord, it therefore bisects this, right? So, which means bisection means now, you are actually required to prove that line AB is going to be equals to what? To be equals to line BC. This is what you are required to prove in this particular theorem. So now, how do you go about proving it? So now, we are going to firstly provide what we call construction. So how do we construct? We are saying now here, we are going to start by saying now, you are going to construct this line. So you're going to say construct, you're going to construct line what? Or you're going to construct line or radius AO, and also what? And you're also going to provide a construction here, which is CO. That's okay. These are going to be the constructions that are required of you when you are starting with this theorem, right? Now, in order for you to prove this particular theorem, you are going to prove congruency between the two triangles, right? So, which means now we are going to firstly do this. You are going to refer. You are going to say in triangle. You are going to say in triangle triangle AOB, and in triangle what? In triangle COB, right? These are the two types of triangles that we are going to be focusing on. And don't forget, when we are saying a line drawn from the center perpendicular, we know that perpendicular is being referred to as your 90 degrees, right? Remember, as soon as something is perpendicular, it forms a 90 degrees, right? So you can label this, therefore now, your B1 and also your B2. Now, when we are starting with our proof, now this is where we are going to start. We are going to start by saying, firstly, if we are referring to triangle AOP, can you see this triangle? You know that now your angle B2 is going to be equal to your angle B1. Okay, because these are going to be 90 degrees and this is given to us. Okay, so you're going to say now your angle B2 is going to be equal to your angle B1, which both of these angles are equal to your 90 degrees. And this is given from our diagram. So we can write this as our given because it is given from our diagram, right? And now from here, we're then going to look in terms of what is it, what else that is therefore common from this, right? Now, if you can look at your AO and also your OC, can you see that your construction lines are your radius, right? So which means you can say now your line AO is going to be equal to your line CO. What is going to be your reason? These are your radius, right? Or these are your radii, or whatever comfortable way you want to call it, right? So this is going to become your radii. And then after that, what else can you find? Now, if you can look at both of these triangles, AOB and triangle COB, can you see that the line OB, this particular line, is common in both of these triangles, right? It is common. So therefore, we are going to say now, again, OB is equals to OP. What is going to be the reason? This is a common side. This is a common side because we find this particular side in both of these triangles. Okay, we find this particular side in both of this triangle. Now that you have proven 1, 2, 3 things, Therefore, you can conclude that basically this triangle is congruent to this triangle. And therefore, congruence means all the angles are equal and all the sides are equal. So if you have proven that all the angles are equal, therefore all the sides are equal, therefore line AB is also going to be equal to your line BC. So, but now you need to provide a conclusion. You're going to say now, therefore, and then now when you're writing this, you need to write the order. You started with what? With B. You followed with what? With A, then O. So which means you're going to say, therefore triangle BAO, which is triangle BAO, is going to be equals to what? Is congruent to triangle what? This triangle of ours, which is going to be triangle what now? We started with what here? It's BCO. So it's BCO. This is going to be triangle BC and O. This is going to be congruent. So now, therefore, since you have proven the congruence of this side, therefore, we are then going to conclude that now, therefore, AB is going to be equals to what? Is going to be equals to BC. But before that, you need to also provide a reason for this. What is the reason for this? Your reason here, remember this is 90 degrees, which means represent your right angle. Your radius, as much as this are your radius, but if you are looking at this this triangle, it's your hypotenuse, right? So therefore it's your H, and then now this is the common side, so this is going to be S. So this is the particular reason that you are required to show when you are proving this theorem 1. Thank you very much.